Have you ever stood in Yellowstone National Park, surrounded by its incredible beauty, and felt a deep, primal rumble beneath your feet? It's a feeling that's hard to ignore, a subtle hint of the immense power churning just miles below the surface. Because Yellowstone isn't just a park, it's a geological marvel, a living, breathing supervolcano. And today we're venturing deep into its fiery heart to understand the ticking geological clock that has shaped our world and continues to define this iconic landscape. So, what exactly is a supervolcano? Forget the classic cone-shaped mountains you see in cartoons. A supervolcano is a different beast altogether. It doesn't build a mountain. It creates a massive depression in the ground called a caldera. Think of it like a colossal underground chamber of magma. When the pressure builds to an unimaginable degree, the entire roof of this chamber collapses, unleashing an eruption so powerful it can alter the global climate. The Yellowstone caldera, stretching an astonishing 45 by 30 miles, is one of the largest on Earth. It's so big that for a long time scientists didn't even realize it was a volcano. They were literally standing inside it, unable to see the forest for the trees. To truly grasp the scale of this power, we have to journey back in time. The Yellowstone hotspot, a plume of molten rock rising from deep within the Earth's mantle, has been active for millions of years. It's like a giant blowtorch fixed in place, while the North American tectonic plate slowly drifts over it. As the plate moves, the hotspot periodically burns through the crust, triggering cataclysmic eruptions. The most recent super eruption, the one that formed the caldera we see today, happened about 640,000 years ago. It's known as the Lava Creek eruption. The sheer volume of material ejected was staggering, over 240 cubic miles of rock, dust, and ash. To put that in perspective, that's enough material to bury the entire state of Texas 5 feet deep. It was 1,000 times more powerful than the 1980 eruption of Mount St. Helens. Ash from this event has been found as far away as California, Louisiana, and even the Gulf of Mexico. It was a planet-altering event, plunging the Earth into a volcanic winter that likely lasted for years, decimating plant and animal life across the continent. But the Lava Creek eruption wasn't a one-off event, it was just the latest in a long series. Before that, about 1.3 million years ago, came the Mesa Falls eruption. And the most monstrous of them all was the Huckleberry Ridge eruption, 2.1 million years ago. This eruption was more than twice as large as the Lava Creek event. It ejected so much material that it created a caldera that would have dwarfed the current one. Each of these eruptions left an indelible mark, sculpting the dramatic canyons, vast plateaus, and unique geological formations that make Yellowstone what it is. The landscape you walk on today is, in essence, the aftermath of ancient apocalypses. So the big question on everyone's mind is, when will it erupt again? The media loves a good doomsday story, often portraying Yellowstone as a ticking time bomb ready to blow at any moment. But the reality is far more complex and, frankly, less alarmist. Geologists have studied the eruption cycle and found that, on average, a major eruption occurs roughly every 600,000 to 800,000 years. Given that the last one was 640,000 years ago, it's easy to see why people get anxious. However, geological time is a very different concept from our human timescale. This overdue status doesn't mean it's going to happen tomorrow, next year, or even in the next 1,000 years. The Yellowstone Volcano Observatory, a partnership between the U.S. Geological Survey, the University of Utah, and the park itself, monitors the volcano 24/7. They use a sophisticated network of seismometers, GPS stations, and other sensors to track every little tremor, ground deformation, and gas emission. They are looking for signs of an impending eruption, like a rapid uplift of the caldera floor, an increase in earthquake frequency and intensity, and changes in the gas composition of geysers. While the ground in Yellowstone is constantly rising and falling, breathing as scientists call it, and thousands of small earthquakes happen every year, there have been no indicators to suggest a super eruption is imminent. The most likely volcanic activity we all see in our lifetimes is a much smaller lava flow or hydrothermal explosion. which, while locally dangerous, would be nowhere near the scale of a caldera-forming event. In fact, the most immediate and visible evidence of the supervolcano's power isn't a threat of eruption, but the very features that draw millions of visitors to the park each year. Every geyser, hot spring, mud pot, and fumarole is a direct link to that massive magma chamber simmering below. Think of the plumbing of a house. The magma chamber is the water heater, and a complex network of cracks and fissures in the rock are the pipes. Rain and snowmelt seep deep into the ground, where they are superheated by the volcanic system. This hot, pressurized water then rises back to the surface, creating the geothermal wonders we see. Old Faithful, the world's most famous geyser, is a perfect example. Its predictable eruptions are the result of a specific underground plumbing system that fills and releases pressure on a regular cycle. The Grand Prismatic Spring, with its vibrant rainbow of colors, is another manifestation of this heat. The different colors are created by different species of heat-loving bacteria, each thriving at a specific water temperature. The cooler outer rings are home to one type of bacteria, while the scorching hot center is too extreme for most life, revealing the deep, pure blue of the water. And then there are the mud pots, like the fountain paint pot. Here, acidic steam and gases rise from below, breaking down the surrounding rock into fine clay. The result is a bubbling, gurgling cauldron of mud, a stark and stinky reminder of the chemical processes happening just out of sight. Each of these features, from the most delicate hot spring to the most powerful geyser, is a safety valve, releasing the immense pressure and heat that builds up within the caldera. Without them, the pressure would build up far more quickly. So in a way, the very things that make Yellowstone so beautiful are also what helps keep it stable. Yellowstone's fiery heart is a place of incredible contrasts. It's a landscape sculpted by unimaginable catastrophe, yet it's a sanctuary for life. It's a testament to the immense destructive power of our planet, but also to its incredible resilience and beauty. Standing there, feeling the ground tremble and watching steam vent from the earth, you're not just a tourist. You're a witness to one of the most powerful and dynamic geological systems on the planet. It's a humbling reminder that the ground beneath our feet is not static. It is alive, constantly changing, and holds a power that commands our utmost respect. Thank you so much for joining me on this journey into the heart of the Yellowstone Supervolcano. If you found this fascinating, please hit that like button and subscribe for more deep dives into the wonders of our world. We'd love to hear your thoughts or your own Yellowstone experiences in the comments below. Until next time, stay curious,